So today, we're going to be talking about immutable infrastructure in production. Now, have you ever had one of those crazy ideas? Everybody looked at you, thought you had 3 heads. Well, that was kind of what we ended up doing was we said, we have this crazy idea. We want to lock ourselves out of production. My name is Martin Searle with AWS Professional Services, and this is Mirza Beg with Experian Consumer Services and Director of Technology for Experian's Consumer Credit Platform. And so we did just that. We locked ourselves out. This is a live shot of Experian's production account. This is just one instance filtered down here. They have hundreds of instances in this account. We just filtered one. And as you can see, this instance, like all the other ones, has no SSH key attached to it. Some of you might be thinking that's not really possible, but it is. We launched the instances without keys. And for those of you that are familiar with EC2, you know that once this instance is launched, there's no going back. So truly locked out of this instance. On top of that, the IAM permissions that we give for the default IAM permissions for our users are just the standard managed policy read-only. So with some additional deny policies, this basically just becomes a way for them to log in and check CloudWatch, metrics, monitoring, that sort of thing. So no changes to production whatsoever. So let's take this from the top. Today I'm going to be talking about why we decided to do this and how we implemented the production steps to get this, the deployment steps to get this into production. And Mirza is going to be talking about the development side and what the development implications were on the development lifecycle, as well as production monitoring so that we knew everything was going smoothly. Also, a little bit of context about myself. I currently work for AWS, but when we were working on this project, I was a full-time consultant working with Experian, so this was really a joint effort and an effort that we were both working on. So, the application in question we're going to be talking about today is Experian.com. It serves credit reports and scores to over 10 million users, has over 100,000 requests per hour, and runs in a fully PCI-compliant environment. Now, why am I saying this? Not because these are big numbers or that I think they're big numbers, or I mean, obviously there's people that are bigger, but so that you understand that this is a real application. This is a tier 1 business critical application, not someone's pet project or some internal app. This is a real life, real world production deployment. So when we started working on this, we thought, well, obviously our first concern is security. We have network security, account security. So how are we going to secure this thing? Obviously, network security comes down to firewalls, right? We're worried about making sure that there's no, all the OWASP top 10 are covered, DDoS protections, using things like security groups and network ACLs and layer 7 WAFs, web application firewalls. And so firewalls are pretty great for that, but what we realized is that the standard deployment model of using SSH punches a big giant hole right in the center of that. And so what are the vulnerabilities and threats that we're talking about here? Well, the standard ones, such as being able to SSH into and out of the instances. Of course, it's very easy to circumvent those firewall rules by being able to potentially siphon data off. On top of that, you run into, how do I control access on the instance? Of course, any standard Linux admin is going to be like, okay, we have users and groups and those sorts of things, but there's a lot to think about there, right? Then we have key management. We have to make sure that we're going to manage these SSH keys. Maybe we'll use something like Centrify or AD, but there's a whole management setup there that needs to be maintained. And even if you do all of that perfectly, even if you manage to get everything right, which honestly we see a lot of customers, this is kind of the last thing they think about, right? I'm sure many of you are like, well, we don't really have time to put all that into play. There's one more thing to think about, EC2 roles, right? So if you've ever launched an EC2 instance, hopefully you've used EC2 roles. And what that allows you to do is to assign IAM permissions to the instance that you can use in your side of your application to call AWS APIs. So you don't have to provision those credentials yourself. We do that for you and rotate those for you automatically. Well, the way that we do that is with the metadata URL baked into every EC2 instance. So we provision those credentials, which can last over 6 hours in time, but we rotate those. Well, that's great, except what if you get SSH access to the instance and this metadata URL is not properly secured? Now someone can take these credentials, go halfway around the world, and start pulling things out of your databases or S3 buckets. So we thought, well, could you in theory solve all these problems? Sure. But wouldn't it just be easier if we went to an immutable infrastructure model? So what does that mean? What does immutable infrastructure mean? How many of you guys have heard the term before? Great. If you've heard the term before, you're probably thinking that sounds impossible. Going back to my 3 heads, maybe we were up to 4 heads after last night. But the thing is, immutable infrastructure is possible. And so what we hope you'll take out of this session is some strategies on how you can implement that. Now, what does a truly immutable piece of infrastructure look like? So we want to look at some models maybe in the real world that we can take into deploying into AWS. So this is an example of a time capsule. Right? In the time capsule, you seal it all up, you weld it shut, it goes hundreds of feet into the earth. Well, obviously we can't just do a total production lockout like that, because I'm pretty sure your business owners and your product owners are probably going to frown on never making any additional changes beyond version 1.0. So we need to find a different model that we can leverage to help get things into production. What about this one? Hopefully most of you still remember what these are. Disposable cameras. I know I used to have one. And disposable cameras were great even if you already owned a camera. Right? I used to own a regular camera, a little Polaroid. But even if you had one, you still had a disposable. Why? Well, because they were cheap. So if you had a few of them with you on your trip, you lost one, it was no big deal. You didn't have pictures in there that you were worried about. Right? So they were easy to manufacture, they stamped them out. They didn't have a lot of components inside that they had to worry about, getting data in and out. So it was actually, you may not even realize this, but it was actually pretty secure, right? It was secure because the only way to get pictures out of this thing was to take it to actually a pharmacy or something, and they would get your pictures off for you. And it was only the pictures that you used that one time. So we really want to look at this one-time use model and shoot for this as our way of getting things into production. So, the goals: no humans in productions, or very little read-only access. And how are we going to do that? We're going to do it by automating everything. We're going to create a production pipeline that helps us get things into production. And so the key here isn't that the infrastructure never changes. We have some very specific goals that we're looking for so that we can accomplish what we're trying to do, which is to make sure that all changes are audited in production and that there's no humans going onto the boxes. So everything has to be automated, no humans in production, and so most importantly, no SSH backdoors into production at all. But something that we all kind of don't think about a lot when we're handling security and putting security policies into place is really the development side. This gets lost a lot. We have these policies, going in, we're saying we're going to lock this down or we're going to, enforce these things, but how does that have an impact on development? Shadow IT, those sorts of implications. And so we knew that whatever we did had to be easy, just as easy and just as fast for the developer as actually going on the box and SSHing or SFTPing their code onto the box. Right? That was an MVP for this. Otherwise, it wasn't going to work. So what we realized is we need to ask 2 questions in order to make this work. Number 1, and these seem pretty obvious, but it's really the fundamentals of how we look at this problem. If we want to make changes to production, how are we going to get those changes automated into a pipeline? Right? We're not going to go onto those boxes, so how do we automate this into production? And number 2, and this is probably the most important one that you're thinking about, how do I get the data I need off the box, right? How do I make sure that if I do feel like maybe 1 or 2 times I need to get onto that box to get some data that isn't in my log, take a step back and figure out how we can get the data we need off the box, which we'll talk about. So, on that first one, we realize we have a target environment that we need to figure out how we're going to do these 5 things. So, from the bottom up. And by the way, I realize someone mentioned to me that this looks like the terror threat model thing, it is not that. No color coordination happening here. It's all coincidence, and they're not in any particular order. But if you look at this from a stack point of view, we have our base instance configuration. So installing Apache, Nginx, your application servers, et cetera. Number 2, code deployment, right? So we got to get the code onto the boxes once we've set it all up. Number 3 is application configuration, such as knowing how much my heap size should be, thread pool usage, thread pool size, et cetera. Next is environment configuration, right? Got to figure out how we're going to get our database endpoints and all of our things that with the environment around us in there. And finally, last but definitely, obviously not least, how are we going to monitor this thing once it's in production? So, you're probably thinking, Martin, the next thing you're about to say is we're going to start baking some AMIs, right? So AMI baking, as many of you know, is very popular, very common, and does work. We have a number of our big customers that use it, right? Netflix, a lot of them have baking pipelines. The challenge that we realized when we were going with AMI baking is that the development times, getting the developers to be able to get their changes into development can be somewhat slow. And so you're looking at spinning up an instance, configuring everything, flashing it. It's a huge overhead. It's a huge headache. And you can sort of work your way around that, but then the issue is your development environment doesn't look like your production environment, right? So you want to make sure that whatever you do in dev is the exact same as in production. And so we thought, how can we, going back to that very important tenet, how can we make this easy for developers and just as fast? And so we didn't think that baking was the way that we wanted to go to solve that problem. So how are we going to solve that problem? Well, here's what the sample pipeline would look like. Code commit, obviously, big fan of code commit. This could be GitHub, this could be any Git repo on-prem, et cetera. We're going to clone that into Jenkins. Do a build test there, standard Jenkins CI stuff, unit testing, et cetera. We're going to package everything up, all the templates that we need for CloudFormation, which we'll talk about in a second, and we're going to send those to CloudFormation, all the deployment information that goes along with that package. And it's going to deploy either a CodeDeploy or an Amazon ECS Docker setup, right? So either one of those, CodeDeploy or Amazon ECS. Now, key here is that no matter which approach you take, what happens next is that you don't do this all over again in every environment. You take this exact same thing that you did in one environment and you move the binaries or the containers on to the next environment, right? Very important. That way you have a really nice audit trail. Okay, so I said the word CloudFormation. Maybe you don't know what it is. I'll give you a really brief primer on it. CloudFormation, really powerful tool to be able to deploy resources and infrastructure into AWS. At this point, pretty much anything that you could want to deploy. There's obviously a couple of resources if you're familiar with CloudFormation that aren't, but most of the common things are in there at this point. So what you do is you take a template with all your resources and you send it to CloudFormation. It's a big JSON document or a YAML file. And it creates a stack for you. And that stack is composed of, like I said, all of those AWS resources. So pretty straightforward. Template has a bunch of JSON stuff in it. Send it to CloudFormation. It creates my resources. Here's what it looks like if you're not familiar. Real quick, we have our stacks there at the top. Sorry about that. Stacks there at the top. And then all the resources associated with that stack are at the bottom. And this could be anything, right? You see we have Dynamo tables in there, Lambda functions, the whole slew of it, right? We deploy everything with CloudFormation. This handles our entire stack setup for us, right? KMS keys, IAM roles, the works. Now, as great as this is, you're thinking, well, that sounds probably pretty complicated to do, right? I mean, we have, this is what an example of a resource looks like. I mentioned it's JSON. And this is one S3 bucket resource. And there's a lot of really powerful tools in here, right? There's a lot that you can do inside of CloudFormation. But what we realized, again, we want to make this easy. This has to be easy. We can't go to every developer and say, you have to do this, or you can't deploy into production. There's no way hundreds of developers are going to be able to learn all the ins and outs of doing CloudFormation properly, right? So we said, well, that's okay, because there's a lot of patterns that we have for our services that we can reuse and leverage into reusable templates. And all you have to do, developers, is give us a simplified version of what your stack looks like, right? So a very simple metadata file that says, here's the name of my awesome service, if I do say so myself. The deployment system, ECS, in this case, or it could be CodeDeploy, maybe also whether it's Python or Java or whatever your language of choice is, et cetera, et cetera. So some simple metadata, and we'll take that and build the templates for you. Because we know, how to take, get an ELB and hook it up to the instances and all that. One thing missing here you're probably asking about is, well, what if I need additional S3 buckets or KMS keys or Dynamo? So we thought of that as well. Again, all the additional parameters around creating an S3 bucket, most of the time most people use, so we don't need to expose most of that CloudFormation functionality to the developers, just a very simple logical ID for the bucket that you're creating. It could be multiple S3 buckets or Dynamo tables, just the minimum amount of parameters needed to get this thing into production. And of course, if we need to add more, we can always add more on request. Keep in mind that logical ID because we'll be talking about it later. So, infrastructure in place. We have CloudFormation, we have all the resources in place, now we're ready to configure the base instance. How are we going to do that? Again, you're probably thinking the next thing I'm going to say is talking about configuration management systems, and there are a lot of great ones out there. But it turns out, CloudFormation actually does a lot of that for you, right? Nothing wrong with any of the other systems, but we're already using CloudFormation. Why not just take advantage of all these tools that are built right in? And what's great is that it's then templatized and available to see exactly what went into that instance in order to see, audit it later or that kind of thing. So packages, users, groups, installing, putting files in the box, running even any kind of generic commands I want, all possible right inside of CloudFormation. And so with that, we have our base instance configured. We have OpenJDK installed. We're ready for some Java services. And with that, I'll hand it over to Mirza.
Thanks, Martin. As Martin mentioned, when we first introduced this idea of not being able to log into production, I have to be honest with you, a lot of us met that idea with the reactions like this. It's one of skepticism. We're about to launch a new platform, hundreds of instances, brand new code base, and we're telling me that the first day we launch this, I'm not going to be able to log into the box. And the reason is because we tend to fall back on what we've done in the past, right? For decades on, we've been logging into boxes to verify code deployments, to check application configuration, check the server.xml files, et cetera, tail log files. This is something we've been doing our entire career. And when you tell us, hey, we're not going to be able to do this, that's met with a reaction of skepticism. Fortunately for us, we had members of the team who were really bullish on this idea of security first, including our leadership. And so we decided, let's take a step back. Rather than falling back on what we know and what we've done in the past, this is an opportunity to build a cloud-native application. What can we do differently? And this is something you've heard in many lectures, but this is really the challenge that when you adopt AWS that you really need to do is challenge yourself to do something in a different way. So we went back and we said, okay, what do we really log into a box for? And what are those needs, and can we do them differently? So the first thing is deploy code. How do I get my binary? How do I get those applications onto the box? For us, what we did is we leveraged AWS CodeDeploy. Many of you are probably familiar with CodeDeploy. It's basically a service which automates the deployment of your binary files onto EC2 instances. Essentially, you have an agent that sits on each EC2 instance that's polling out constantly to CodeDeploy, saying, is there a new deployment ready for me? Is there a new deployment ready for me? And when there is, it goes through those series of actions to deploy the application. And it manages the binaries on, you can choose either GitHub or on S3. The other really nice aspect of this is that it works seamlessly with the auto-scaling groups in EC2. So you're able to do rolling deployments. You don't have to worry about taking your service down completely. You can say, okay, take one instance down at a time, do a rolling deployment of my service, and make sure that you have uptime at all times. So CodeDeploy has worked really well for us. As I said, it works seamlessly with both the ASG and the ELBs. Now, you may be thinking, well, okay, it's not that simple. I don't need to just get the binary on the box. There's a lot of pre-steps I need to do in the installation. There's some validation of the service. I really need to be on the box to do some extra steps. Fortunately, CodeDeploy is actually pretty flexible. This is a sample of an app spec file that's included with every deployment. As you can see, it provides hooks for you to basically add custom actions before and after the install, how the application should start up, and very importantly, how to validate the service after it's started up. Right? I mean, typically, we've always done that, tail the log file, make sure it's listening on 8080 or whatever it is if it's a web service. You can write scripts to automate that validation. And once those steps are complete, then it'll work with the load balancer and the auto-scaling group to include this application back into to the ELB. So that works out well. Now, you may be thinking also is, okay, well, what happens when things go wrong? You know, how do I debug code deployments? Because, and I can tell you from experience, this happens to us quite a bit. Not quite a bit, but it's happened to us enough, especially in the early processes. So how do you get visibility when something goes bad in terms of a deployment? Fortunately for us, also, CodeDeploy actually gives you pretty detailed auditing of that deployment. As you can see here, it basically lists out every step of the process, the duration, the status, tells you which instances, if you're deploying across instances, it succeeded on. And in the case of an error, you have a pretty detailed event log as well that helps you identify the problem. And you know, having been in production, leveraging the system for a while, I can tell you that that has actually really helped us tremendously. So now we have the base instances configured. You know, we've potentially solved our first problem of deploying code and getting the application running on the box. Then the typical second thing that we normally like SSH onto a box for, from a development point of view, is to configure the application. How do I set how many threads are going to be processing requests, what the listen ports are, et cetera, feature flags. How do I do that if I can't get onto the box? For us, what we did is we adopted this notion of self-discovery, right? Like any microservice architecture, we're talking about managing hundreds of instances of hundreds of services across. We don't want to be logging into boxes to manage configuration over there, right? So the notion that a service has to be able to discover information about itself. And this isn't really anything fancy. It sounds fancy, but it's 3 basic steps. The first for us was to leverage the metadata URLs. Let me take a step back. Remember that EC2, leverage the metadata URL. So this URL, and on any EC2 instance, this is actually very similar to what Martin showed earlier about getting the access keys. You're able to get a document that tells you about the instance itself, right? And for us, what was key here is the instance ID. This is the first thing that gives a service kind of bearing about, hey, who am I? It comes up, it gets an instance ID, and now it can leverage the second step of the process, which is leveraging the AWS SDKs. So now when a service comes up, the first thing, once it grabs an instance ID and knows who it is, it's able to leverage the SDK to get a little bit more information. And what we did is we leveraged EC2 tags. If you remember when Martin talked about CloudFormation and the template and it creating all the resources, it obviously created these EC2 instances as well. So it had the opportunity to inject custom information into the EC2 tags for each instance. And so this provided a lot of flexibility for us. Now, you might be tempted to start putting more configuration information in here, but just a caveat to this is that you don't want to put any, especially secure information in here, right? Because this is not encrypted. It's available to anybody who has access to the console, et cetera. And it's not something that you can manage easily by changing very often. So we just want to put the minimal amount of information that the instance needs. So for us now that I have the instance ID, I've leveraged the SDK to get a little bit more information about my environment, what's the name of my service, I'm running in prod, and very importantly, where the arrows point to, where do I go to get more information, a config location. And this could be an IP address, a Dynamo table, whatever it is. So that leads to step 3 of the process, is leveraging a secure configuration repository. So once the service is up and it knows where to go, it can reach out and get the data it needs. And you can use several tools out there. You could use something like Console. If you're a Java shop, you can use Spring Cloud Config. Even custom solutions like DynamoDB or Amazon S3. The nice thing about Dynamo and S3 are you have very granular IAM permissions that make sure that only your service can access that particular bucket or that particular table or even that particular primary key in a shared table. So once the application has this, then it's able to retrieve its feature flags, thread pool sizing, listen ports, etc. And now the application can come up in function. So now we have the instances configured, the app is up, and now it's time to talk to the outside world. And for that, I'll hand it back to Martin.
Thanks, Mirza. So at this point, you're thinking, OK, if you're familiar with deployment models, you have, on the one hand, fully baked AMIs. On the other end of the spectrum, you have fully bootstrapped instances. And so far, we've talked about the fully bootstrapped model, right? And if you're familiar with it, you probably think there's some potential downsides, some potential challenges with this model. And that would be accurate. So there's a few. So there's really two main ones. But the two main concerns would be, one is this: how do I go out and get packages and libraries from the instance? How do I make sure that's secure? It's not being man-in-the-middle attacked, things like that. Also, for stability, we want to make sure that you're not just getting maybe latest. You want to get version dependencies. And there's a couple of concerns there, but we found that you can mostly mitigate those through local repos, using Artifactory, Nexus OSS, things of that nature, and making sure that you're explicit in your dependency management inside of your application. The other one is auto-scaling. So obviously, when you're fully bootstrapping instances, and when you're auto-scaling, you're going to end up with a couple more minutes of auto-scaling time. And what we saw in practice for us was leveraging Amazon Linux, which has a lot of stuff pre-installed, really only installing OpenJDK, for example, for Java instances, maybe a couple other minor dependencies. It wasn't really going to take that much longer to auto-scale, maybe another couple minutes. And in general, if we were auto-scaling, we knew that we were going to have an email campaign. It was going to be mostly pretty predictable, so a couple minutes of auto-scaling wasn't a huge deal. But there is a potential, if you do have a need for really quick auto-scaling, that there might be some concerns with this bootstrapping model. And in general, maybe what we're thinking of is, OK, so far we've talked about how to lock ourselves out of production, but it hasn't necessarily been a strictly immutable piece of infrastructure, right? We are making changes with CodeDeploy, which again is automated and it meets our goals, but it's not 100% immutable, and there's some potential challenges. So maybe is there a way that we can combine those first two layers there and combine code deployment with the base instance configuration to make a more immutable component there for those bottom two, and make it faster for auto-scaling and easier to deploy? And so, of course, in 2016, I have to talk about Docker. So what is Docker? Probably most of you know, but real quick, I'll review. Docker, essentially on the left-hand side, that's your standard configuration there. You have a hypervisor. You deploy everything right on top of the hypervisor in your main OS, your guest OS. And then your other model is that you use the Docker engine, which is what Docker does, which allows you to essentially deploy your applications inside of a process container on the standard Amazon Linux images, right? So essentially, Docker runs as a process inside of the operating system and creates kind of a virtual OS container for you. And so it just helps to just really honestly look at what a Docker file looks like, a standard Docker file. So this is honestly a standard Python app, Flask app that you would use, hello world. And as you can see, I literally do everything from top to bottom on bootstrapping this thing inside of my Docker file. So no changes needed to the application. I simply say which distro I want, what ports I want to expose, which things need to be installed. Just like I was showing before with CloudFormation, I put that into a Docker file. Now, if you're not familiar with Docker, you might be thinking, well, OK, that's still a couple hundred megs, right? That's still going to be the same challenge as AMIs. You have to pull down the images. It's going to be slow. But it turns out that Docker is extremely intelligent about how it layers its containers. So every container is layered based on each line of that Docker file. So if I only make changes to the bottom two layers there, it's only going to be very small changes that get deployed into production. So it's very fast. There's not a whole baking process that has to go into place. Docker builds are very quick. And of course, most importantly, it allows me to take a container locally, starting 100% locally, and move it all the way through to production. And have a completely immutable, it uses SHA hash to make sure that nothing has changed going from one environment to the next. So really powerful tool for auditing. And even if you're worried from a security perspective, well, how am I worried about, if I'm worried about container security, et cetera, even if you only run one container on each instance, you still get a lot of those benefits. So, got those bottom 3 layers covered, and now we're ready to configure the application. And there's a lot to configure, right? Dynamo tables, KMS keys, SQS queues. How do we figure out what all those endpoints are? Well, remember Mirza talked about those EC2 tags. CloudFormation puts the stack name right there in the tag for me, right? And so every one of these EC2 instances that I deploy with CloudFormation, I can use that when I'm getting all those tags and know exactly where to go and make an API call to list stack resources and get all of the resources that were deployed as part of that stack. Now remember I said don't forget about the logical IDs earlier. This is important because there's a physical ID mapping. So that logical ID that the developer put into that metadata for their S3 bucket or Dynamo table now has a really nice mapping to a physical ID that they can use inside their code and make calls out. And of course, Mirza and his team built a library to help abstract this away from the developers. One last thing is credentials, right? How am I going to manage credentials? Am I going to have some kind of vault or something like that to keep credentials in? And you might say, well, this is sort of a cop-out, but we actually didn't have any credentials. Why? Because we use Dynamo, we use S3, we use SQS, and you're probably familiar enough to know that when you use these managed services, you don't have credentials. EC2 roles handles all of your credentials for you, or if you're using Lambda, then that has built-in rotation of credentials. So you really don't, when you're using that model, you don't even have to worry about provisioning credentials at all. If you do need something like RDS databases, then you can still leverage the same IAM permissions using KMS to encrypt those credentials that are generated when the database is started up, and encrypt those and put those maybe into environment variables or something like that. So, with that, everything's into production. We're ready to start monitoring that. For that, I'll hand it back to Mirza.
Thanks, Martin. So now the application's up. It knows how to configure itself. It knows how to speak to the outside world. And then the question becomes, well, how is it running, right? How is it performing in production? And this is something that many of us have always logged into the boxes for, right? This is probably the #1 primary need of why we even need to log into boxes, is how do I validate everything's going well in production? A good day in production may look something like this, right? This is a sample of an app dynamics dashboard where each of these nodes represents a service, could be multiple instances in each. And green is generally a sign of good, right? This is what we hope for, and this is the kind of the standard that we're trying to meet. And at that time, we really don't need SSH. We're not missing it. It's not a problem. But what happens when we get that page at 2 in the morning? We log in, and the dashboard looks like this, right? I mean, many of us have seen that where we're just waking up, and we're logging in, and wow, everything is down. What do I do now? Right? Now I've locked myself out of production. Is my reaction going to be something like this, where I can't go back to what I've done in my entire career? I need to do a kill-3. I want to run a thread dump. I need to get onto the box. What am I going to do? And so for us, we had this notion of keep calm and turn debug on. And what I mean by that is we really didn't turn debug on in this case, but quite honestly, the amount of information that's available in this environment, it's as if you have debug on. The first thing is leveraging like CloudWatch and so on. You have so many metrics available to you, so much data available to you, it's almost as if you had debug on. So first thing that we had, principle that we had was that all logs are immediately shipped off of the box, right? Is that we had to be comfortable with log data being immediately off of the box, no need for somebody to keep an instance alive for us to be able to log into it. That we're not going to lose anything. We're not going to lose any sleep if an instance dies at any given time. And there's many tools you can use, obviously, for that, right? Logstash, Elk. You can use Splunk, et cetera. You can also write to the CloudWatch logs, and you leverage the subscriptions there. So you really want to build that real-time dashboard that gives you very good visibility into your production system. And this has to be key, obviously, with microservices, and it's critical, especially if you can't get onto that machine. The other thing, obviously, is proactive monitoring, right? As I mentioned, you have so many metrics available to you through CloudWatch, whether it's CPU utilization, disks, memory, et cetera. You can also, and this is what we do as well, is leverage an APM solution, such as New Relic or App Dynamics, and now the new one, X-Ray, right? So there's a lot of tools that are available to you to monitor this proactively up front. And the other thing is also that's helped us is building in advanced health checks. If you're using something like Spring Actuator, and there's many packages that do this, but this is just one example, you get built-in health checks that are available to you. You get built-in routes that provide metrics, service information, thread dumps, even environment information. You want to really bake that into your application up front so that when things go bad, you're not looking at, I wish I had this information. It has to be baked into the process up front. And that was really key about making the decision to turn SSH off in production up front. That drove us to enable a lot of these functionality, because typically if you have that concept available to you, then you're less motivated to build a lot of these things up front in your application. So what are the other implications on development? So now we're feeling pretty good about monitoring the application. We know what's going on. We have good visibility into it. What are some of the other things that we had to consider? The first, as I mentioned earlier, is that all instances must be ephemeral. We have to be comfortable with an instance being terminated at any given time and have no angst about it. And this is really, it fits the microservices paradigm. So there's no application state that's written to the disk. This is, again, key for auto-scaling, right? Because you want to be able to scale up and scale right back down without having any consequences for that. And the other thing is, really, to make this possible, it has to be cheap to manufacture. Going back to that portable camera, right? If the camera breaks, you just throw it away. There's no angst. You're not going to lose any sleep over it, because there hasn't been a human that went into production, configured the server, spent the weekend getting a brand new instance up. It was literally a matter of logging in, going to the auto-scaling group and saying, yeah, you know what, go from 3 to 6. That was it. That's what took it to go to 6 instances, and that's what took it to go back down. So there's no emotional attachment to instances. Then, we always have to ask ourselves, okay, what happens when something really bad happens, right? Like, what if I really need access to that disk? What am I going to do? Maybe it's for forensics reasons, et cetera. The nice thing is, if you have an EBS-backed instance, you kind of follow the standard protocol that you would if you lost your SSH key, for example. So you can snapshot that instance, mount it to another instance with SSH if you need to, and you'll be able to access the disk if you really have to do that. What about if I need to do like a thread dump? I'm trying to troubleshoot deadlocks, et cetera. You can put in standardized logging on startup and shutdown sequences in your application that give you this information up front. The key is really to kind of think about what are you going to need when that happens, and try to make sure you put it in up front so you're not left at 2 in the morning wishing you had that data available to you. So then, we're feeling a little bit more comfortable now about the application running, and we know that nobody's logging into the box. They're not changing config. They don't have access to credentials on the box. So we feel good about that. Then the focus for us, from a development point of view, becomes how do we secure that code pipeline, right? How do we make sure all changes are versioned accordingly that are getting onto that box? We also have to make sure that the ability to deploy code, right, through CodeDeploy, for example, is controlled through IAM roles, and we have to have close watch on that process. And the nice thing is you have, CloudTrail logging that tells you who initiated deployments, when it happened, et cetera, and you can create alerts on this as well. On the development side, we also have to make sure our source code is sanitized too, right? Because now we're dealing with, since nobody's logging onto the box physically, how do you prevent malicious code from being deployed there? So really, it's focusing back on having a green room environment, like a Nexus OSS, et cetera, and maintaining clean package dependencies. If you're using Maven or Ant, you can put in like an OWASP dependency check, where it'll check all the dependencies that you're pulling in, and it'll tell you if there's any known vulnerabilities within those packages. Then it's also adding static analysis to your code as well, right? So you can leverage tools like Parasoft, Fortify, Veracode, et cetera. There's a whole variety of tools out there. But the focus becomes securing the pipeline of the code before it gets onto the box. And with that, I'll transition back to Martin.
So, one more note about the pipelines. At professional services, we consult with a lot of big enterprises doing migrations. And one of the things, I work with the security team, our security practice. And one thing that we're really focusing a lot on is this idea that rather than dealing with security on the instances themselves, we need to get earlier in this process. Talk about DevSecOps is a big buzzword now. And really, in order to scale security, you really need to be earlier in the process in a more automated and secure way. And so we do a lot with this, and I definitely encourage you guys to look at more of some of the DevSecOps tools to help with that pipeline automation. So we've done all of that, and you might be thinking, some of you might have even tried to implement, a break glass in case of emergency scenario, right? If something goes wrong, maybe I'm going to have an SSH key in S3 somewhere. You're probably saying, Martin, isn't that okay if we just have like one secured key? And the challenge is that not only are you going to have that key floating around, but then you also still have SSH installed on the boxes themselves, whereas otherwise you wouldn't. You could just, uninstall SSH, lock down those ports, et cetera. But in this case, you would still have to have that installed. This kind of goes back to that conversation earlier this year with backdoors into devices, right? Once that backdoor is there, anybody can use it. So, no break glass in case of emergency. No backdoors into production. And that brings us back to our 2 questions that we talked about at the top of the session. The questions that we asked, no matter what the scenario, there might be some alternative problems here. You're probably thinking, what about this? What about this? But my answer is always going to be, let's ask the same 2 questions. How are we going to get changes into production in a completely automated way so that it's always auditable? And how are we going to get the data that we need off the boxes so that if we do need to debug, we can do that in dev, get our information, and push it all the way through to production? And so, because we think we were able to solve this, this is what we were able to do with our production environment. No SSH keys and lockdown permissions. And so, we started this 2 years ago, and in 2 years, the number of times we've logged in is 0. Thank you very much.